All right, lesson 9.5, rational equations. Again, as before, we might break this into two parts to focus on two kinds of questions that you'll see. But we are going to look at something totally different this lesson, and that is that even though they are still rational functions, we have an equation. So before where we were adding fractions by getting a common denominator, now we're actually able to solve. So a rational equation is an equation that contains one or more rational expressions, point being equation, and with that we would basically mean it has an equal sign. And when we have that, we can actually solve. Now what happens with an equation is that when we solve it, what we called excluded values before now takes on a new term, a new phrasing, and that's extraneous solution. So we know that an excluded value is a number that would cause a denominator to become 0, therefore undefined. And now what happens is, and we know that we cannot have that value in there because of it causes, again, the denominator to be 0. So if you were to solve and get a number that happens to be at the same time the excluded value, we would call it an extraneous solution. So we solve, we get a number, we notice that that number is an excluded value, in other words, a number that could cause a denominator to become 0. And because of that quality and that characteristic, we would call it a new term, an extraneous solution, a solution that does not check if we plugged it back in. Okay, now there's two kinds of questions we're going to look at. One is when you have one rational function equal to another one, which means only one fraction on each side of the equation. And when you have that, it actually is something that we've had before, and that is that we are creating, or we have been given, a proportion. And to solve a proportion, we just cross multiply. So a rational equation with just one function on each side, or one fraction on each side, is pretty straightforward and pretty familiar. So if we cross multiply, then we would get, and I'm going to write this out, it would be 4 parentheses times x minus 3, or excuse me, x minus 1 equals 7 times parentheses x minus 3, and that's what the cross product would give us. All right, so if we solve that, I would distribute the 4 and get 4x minus 4 equals, and then I would distribute the 7, so 7 times x times 7 plus, or then 7 times negative 3, so it would be a negative 21. This should be an equal sign, sorry. All right, so that's what happens when we distribute. You have to remember to distribute. Then we'd solve for x. Well, if I subtract 7x from both sides, and I'm going to get negative 3x minus 4 equals negative 21. And then if I add 4 to both sides, again, I'm solving for x here, we get negative 3x equals a negative 17. And we would divide by negative 3. Correct? And that just reduces then to positive 17/3. So x equals positive 17/3, or 17/3, which is I think 5.3. And in checking that, it is actually 5.6. Okay. Now, if we looked at the beginning, we would say, well, what are excluded values? Well, I could not have a 3, it could not be a 3, and it could not have been a 1. Now, 5.6 are neither of those, so 5.6 is okay. The next one, I'm going to do this one two different ways. So work with me on this one. I'm going to follow the same pattern here. I'm going to cross multiply. We have one fraction equal to one fraction. If I cross multiply, I'll get 10r equals 2 times r minus 8. I distribute the 2, and it will be 2r minus 16. I subtract 2r from both sides. That will give me 8r equals negative 16. I divide by 8. So I'm just putting it underlined here so it looks like division. And we have r equal to negative 2. Now, the denominators in both fractions are constants. There's no variables, so there will not be any excluded values when you have just constants. It's when you have a variable that you have to be careful about. So r works. Now I'm going to do this another way, because that's going to lead us into the next type of question where we have more than just one fraction on a side. And what happens is, or what I'm going to do is, I'm going to take the same thing, I'm going to take away this here. Now, I'm going to approach this a little bit differently. I'm going to say, you know, what's the common denominator here? Like we were doing as if we were adding or subtracting. And the common denominator would be 20. So I would take, if I were to add and subtract them, again, it's an equation, so we're not doing that. But again, bear with me. If I wanted them to have a common denominator, I would take the 2 times, actually 20 is too big even. 10 is the common denominator, that's even better. That would be the least common multiple, so I'm teaching myself something here. I was going too fast. 10 is the common denominator. So I'd have to take this one times 5 to get 10, and this one times 5 to make sure that it's a proportional fraction. But what that does is it gives me r minus 8 equals 5r over 10. And let's see, so negative r minus 8 over 10 and 5r over 10. Okay, so we have changed this now, so it looks like this. Okay, now what does that mean? Well, if you look at it, okay, and if you look at it, you have two fractions set equal to each other, and they both have 10s. So how can they be equivalent? Well, the denominators are already equivalent, aren't they? So what happens is when you have this common denominator, I can actually just ignore the bottom and focus on the top and say, you know, actually, all I really want to find out is how can r minus 8 equal 5r? Because the 10s are already the same. So really, by having a common denominator, we can get rid of the denominators and focus only on the numerators. And this is extremely powerful because we have a fractional equation, okay, rational equation, and fractions are hard. They're hard to work with. They cause some stress, some anxiety. So we have now seen that we can actually, with getting a common denominator, go from a fractional equation, a rational equation, to a non-rational equation, which looks like something we've done a lot of. So I'm going to solve this one for r. I'm going to subtract r from both sides. And that's going to give me negative 8 equals 4r. I'm going to divide both sides by 4. And in doing so, then, I have solved for r, and r is equal to negative 2. Again, is negative 2 an extraneous solution? Would negative 2, can I plug anything into the denominators? No, there's no variables, so negative 2 is not a problem. But with this approach, it's an approach we can use on the next type of questions we have. We got a common denominator. We were able to ignore the denominator part and focus only on the numerator part and ask how they can be equivalent, because the denominators were already equivalent. Now there's two approaches to doing this method. This is one, and I'm going to kind of follow this lead, even though the next box of key concepts apply the other approach. And I'm going to show you both, and it's going to be up to you to decide which one you want to do, but I think that the one I just showed is a little bit clearer, and it ties in better with what we've been doing. Okay, so let's take a look at this, and I'm going to work on these two, and I think I'm going to work on the first one here and do it two different ways and let you decide what to do. All right, now first things first, we have now more than one fraction on one side. That causes us to look at this differently. We cannot cross multiply. I can only cross multiply if I didn't have this one here. If I took this out, then I could cross multiply because it's one fraction equal to one fraction. But we have two things. So now we're going to actually rely on our ability to get a common denominator. So what will that common denominator be? Well, we've talked about this before. We have 3n, 2n squared, 2n squared. 3, 2, and 2. What's the least common multiple for 3, 2, and 2? In other words, what would be the common denominator for those numbers? The first number that they can all go into is 6. Okay, so I want that to be 6. I want to write this over here. 6, and we're going to take the variable with the highest exponent. That's my common denominator. So to get a common denominator, this one would have to be multiplied by 2n, top and bottom. This one would need to be multiplied by 3 to make it a 6. Again, top and bottom. This one would also need just the 3, so multiply top and bottom. And what's that give us? It gives us, I have to multiply the top, so it's going to be 2n plus 3, because it's 3 times 1, equals, and 3 times 3 is 9. Now on the bottom, we'll have the same denominator. Now actually, I am going to type it out for the first time here. So it's 6n squared again, you'll see why I don't even have to do this step once we get comfortable with it. Again, I'm just showing my work. My airliner doesn't work very well, so I don't want to just use my mouse. It makes a big mess. So here's what we got. Notice my top number in the first fraction became 2n because I had to multiply it by 1. Second fraction became 3 because 3 times 1. And then 3 times 3 is 9. Now, like before, I want to find out what makes this equal. Well, the denominator is already equal. So I can just focus on this part from this point on, which means all I need to focus on is 2n plus 3 equals 9. Okay, so I'm going to subtract 3, and that gives me 2n equals 6. I divide both sides by 2. And that gives me n equal to 3. Now again, what would be considered an excluded value? Well, n for all these scenarios here in the denominator could not equal 0. That's an excluded value. Did we get 0 when we solved? No. 3 is what we got, so that means 3 is okay. All right, now I'm going to stop with this one. I'm going to show you another method on our next part. So this ends 9.5 part A.